All right, so this is my 5th hour class. We're doing lesson 3.2. So 3.2. Okay, we're going over this. Now this is going to be hashtag 75. So please make sure you are labeling these things as we go. And today's date is 15. All right, so we have everything here now. So let's go ahead, and I'm going to go through and show you, because this one is easier to see if I have the different colors on this one. And I just had a pile of colored pencils, and I moved them. Oh, there it is. All right, it says find the area of the square. This is the square that I'm talking about right here. So I'm going to show you a neat trick to go along with this. Find the area of this. There's a couple things we could do. So to find the area, we could actually do a subtraction, or I could actually try and figuring out that this side right here is going to be a certain length, and I do the same thing to figure out this side. Now, anyone recall how I would find the length from B to C right here? I heard something. Yep, there we go. Pythagorean Theorem. Pythagorean Theorem would give me a squared plus b squared equals c squared, where a, b, and c. So a is going to be 2. 2 squared plus 3 squared is equal to c squared. And going through this, I'm going to look and see. I have that this is going to be 4 plus 9 is equal to c squared. 13 is equal to c squared. Now, how do I go through and undo that square? Square root. So I'm going to square root both sides. So if I square root both sides, I'm going to have c is equal to the plus or minus square root of 13. Okay, this is super important to remember the plus or minus part. But since I'm talking about a unit with length and measurement, am I going to have a negative length? Someone say no. No, we're not going to have a negative length. It's always going to be positive. You don't have a ruler with negative 5 inches on it. So it has to be positive. So this is going to be square root of 13. So that's this one right here. Now, let's do the same thing for this one over here. So now I'm going to do this one on this side. And I'm going to do Pythagorean Theorem again. So if I do Pythagorean Theorem, it is a squared plus b squared equals c squared. So in this case, my a two squared, okay, plus 3 squared equals c squared. Now, is this the same thing that I had over here? If it's the same thing, do I need to show all my work again if I already showed it there? No, I know it's going to come out to be c is equal to the square root of 13. So I'm going to put that right there. Now, how do I find the area of a square? Length times width, right? So area is equal to square root of 13 times square root of 13. You agree? Jonathan, you're making that face. So it's this times this, right? Length and width right here. I'm just talking about this one in here. So this times this. So now if we go by what we did yesterday, what could I rewrite this as? What can I rewrite this as? Very good. So it's square root of 13 squared, right? Because I have two of them, right? And if I'm squaring a square root, what happens if I square a square root? It cancels out. So my answer is going to be 13 units squared, because it is area. Do what? Yeah, we kind of had to get these two numbers in the first place. We had to get these two. Oh, right here? No, just multiply those together. I showed in the way that we did it yesterday, so we could combine it and see. This would give me the square root of 169, and if you put square root of 169 in your calculator, or the square root of 13 times square root of 13, will still just give you 13. Okay, so yes, you are going to get that. All right, so let's see. Squares and their side lengths. Complete the table with area each square in square units and its exact side length in units. All right, let's try this. What is the... Oh, wait, wrong color. That one doesn't work very well. What is the bottom here? How long is that bottom? 1. How tall is it? 1. So what is 1 times 1? So it's 1 unit squared. And the side length we said was 1. All right, this next one, this one right here. How can I figure out the area? I could. I don't need it, though. I could use the graph to tell me the area. Is it what? It's not half. It is. Who got 2? How'd you get 2? 'Cause what? Okay, I'll show you. I'll show you how I got 2. So I'm going to take this piece right here. And I'm going to take this piece right here. Are they both half a square? They're both half a square, right? So together the green ones make 1 square, don't they? Yes. Now let's take a look at these ones right here. I got this red one, which is half a square, and this other red one right here, which is half a square. So together those are going to give me 2. My area is going to be 2 units square. Please put it away in the bag. I know. I asked for you to put it away, please. It's flashing. That's why I'm asking. Now, let's go through and use this right here to try and figure it out. So I'm going to do again with Pythagorean Theorem like I did on the first one. So off to the side over here, I'm going to do my Pythagorean Theorem. So it's going to be, my bottom is going to be 1. 1 squared plus the height up is 1 squared is equal to c squared. And 1 squared is, say 1, plus 1 squared, which gives me 2 equals c squared. And then c is equal to the square root of 2. Now, again, plus or minus, don't forget that. And since we are dealing with a length, a measurement, it's always going to be the plus in that measurement. So this is going to be square root of 2. Next one. I got to try and darken this one in. This one's not very good. Last time I went over this, I actually skipped c for some reason. I couldn't even see it. It's too lined up good. All right. What's the area of c going to be? 4. There's 4 squares, isn't it? 1, 2, 3, 4. 4 square units. So 4 units square. What's the side length going to be? 2. Because look, side length is from here to here, right? All right, next one, D. Let's see if you could actually figure out D. You got to show me how, too. Huh? Do it the same way I did B. If you do it the same way I did B, you got to be creative on it. Yep. Now watch this. Watch how. So I'm going to break it up same way I did B. So I'm going to do this. I'm going to say this right here. And this one right here. Oh, wait. Not that far. Only to right there. Those two together, if you notice, these two right here can fit together, can't they? So when they fit together, how much does that make? It makes 2 if they fit together. Now I'm going to do the same thing up here. There we go. Again, these two fit together. So that makes 2 more. And then I have 1 in the middle, so that's going to be 5. That's going to be 5. So I'm going to have 5 units square. Let's go ahead and figure out the side length. So we know that this is going to use Pythagorean Theorem again. So in my Pythagorean Theorem, what am I going to use? 1 squared plus, let's look, it's a 1 here and it's 2 here, isn't it? 2 squared equals c squared. So 1 squared is 1, 2 squared is 4. Together that's equals c squared. C is equal to plus or minus square root of 5. And again, always the length is going to be a positive. So this is going to be square root of 5. All right, how about E? You get 8?
No, 6. 6. 6. Where are you getting 4? There's 4 sides. There's 4 sides and 4 in the middle. That is 8. The top 2 make 1. The 2 on the side. What?
So if I put this one here and this one right here together, how many does that make? It's going to be 4, isn't it? So if I take this and I put it over here, it's going to complete this, right? So that would be 4 together. And on this one right here, same thing, isn't it? So if you cut it up in different ways, there's also another way to do it, to do the big box in the middle and a bunch of little triangles around the outside. That's fine. That would still get you the same thing. So what is the total now? 8. It's going to be 8. All right, so let's try and figure out the side length here. So this one right here is 2, and this one is 2. So it's going to be 2 squared plus 2 squared is equal to c squared. So that's 4, right? 4 plus 4 is 8. C squared. C is equal to plus or minus square root of 8. square root of 8. You notice a pattern to this? You guys notice the pattern or no? What is square root of 1? Square root of 2 is? Square root of 2. Square root of 4 is? 2, right? Square root of 5? Is square root of 5, right? Okay, that doesn't, it's not perfect, so, and square root of 8 just gives me square root of 8. It's not going to be a perfect number. So if I were to get to the next one and said square root of 9, you would say 3. Because square root of 9 is 3, isn't it? Okay, so just like right here when I did square root of 4, it gave me 2. That one is a perfect, so it's not going to give me a weird decimal. Alright, let's see if you guys figured out the pattern then. If my area is 9, what is the side length? 3. If the side length is 4, what's the area? I heard it. 16, right? So it'd be like saying this squared, right? So it'd be... Okay, so, and this is 16. What is the side length here? Square root of 23. And 6.4, you probably need a calculator for that one. So how are we going to do this one? I need a calculator to get that one, right? What is it? 4096? Like that? And how do I figure out this one? Square root of 89, right? You don't need a calculator. Don't need a calculator on that one. Just make it easier. Just do the square root of it like that. Just hit OK. I know. I gotta try and I gotta reinstall my program so I could try and fix that. Needs an update. It's all messed up. All right. So, you guys didn't think you guys come to school today and learn how to draw a cube, but we're going to do a three-dimensional shape right now.
Oh, yeah.
You got this? Okay. Draw a square as best you can. All right, so we're going to make this thing three-dimensional. So, after this, I always like going up and to the right. You can do it in different directions, though. Up and to the right. So I'm going to take this corner, and I'm going to go up and to the right. So now, at the same distance and the same angle, I'm going to do the same thing on this one. And same thing on this one. Okay, then do it. Yours better be looking amazing then. And try and connect the dots. There we go. There's my cube. There's my three-dimensional cube. And if you want to be all fancy and give it like the shadow lines, there we go. With the shadow lines too. Super fancy. Yours better look great. No! When? I don't know that guy. Oh. Alright, you ready? This cube, okay, the volume of a cube is equal to length times width times height. But for it to be an exact cube, all the sides are going to be the same. So it would be basically volume is equal to whatever my length is or width is. So something cube, because they're all going to be the same. So, if a cube has an edge length of 3, what's the volume going to be? Say it. 27. Because it's going to be 3 times 3 times 3. So that's going to give me 27 units cubed. Yes, you may. All right, let's look at the next one. That's it. A cube has a length of 4 units. What is the volume? What is it? 42? 32? All right, let's try it. So it's going to be 4 times 4 is 16, and 16 times 4? 64. So if you're using a calculator, you got to use the little caret button. So it'd be 4, and then the button, it looks like this, is a caret, and then it would be 3. So 4 caret 3 is going to give me 64 units cubed. Okay, so now this one, it's going backwards. It says this time a cube has a volume of 8 units. What is the edge length? It's going backwards. It's what? It is 2. Very good. So this, on this one right here, it's going to look like this. It's going to say 8 is equal to x cubed. And to undo a cube, we need to cube root. Cube root. Square root is 2. A cube root is 3. So in your calculator, it's a little button that looks like this. Going to look like that. And you would put a 3 in there, and you put the 8 right there. So this is going to be 2 units, and it is linear. It is not a volume. Okay, were you guys able to find this one on the calculator? I believe it's control, then square root button will actually get you that.
So just 2u?
Yeah, it's 2u. It's linear. It's not, there's no depth on it. All right, so what about a cube has a volume of 7 units? What is its edge length of the cube? Even easier. You don't have to put it in the calculator. Can I say cube root of 7? It's the same thing because you're just finding the cube root of each one, right? So this would be considered an exact answer. And the, what'd you say, 1 point something? Yeah, 1.91 blah, blah, blah. Yeah, that one's going to be an approximate answer. All right, for 5, it says the cube root of 1200 is between 10 and 11 because 10 cubed is 1,000, 11 cubed is 1331. Determine the whole numbers that each of these lie between. All right, so I'm going to do this. I'm going to show you guys a nice number line for this. Actually, I think let's do it down here on the bottom. We'll fill it in right here because it's going to be helpful later on. So hopefully you guys could use it then too. All right, so what is 1 square or 1 cubed? What is 2 cubed? 2 cubed is 2 times 2 times 2, right? 8. 2 cubed is 8. So now I could work it backwards also. Because it's easier to do this than to go the other direction. Watch. Cube root of 8 is 2. So you just rearrange this. The cube root of 8 is 2. Let's do the next one. 3 cubed. That's 3 times 3 times 3. 27. So I could say this again, that the cube root of 27 is 3. Does that make sense or no? Kinda? Kinda. Okay, let's keep going then. Now, fill this in for your own purposes right now. And you can use your calculator on this. Alright, should be about there. Class. Oh, that's so weak. Class. Oh, still weak. Anyway, 4 cubed. 64, 5 cubed. 6 cubed. 7 cubed. 8 cubed. 9 cubed. 7 what? Thank you. Alright, so let's use this as my guide to answer this next thing. So, the square root of 5, or I'm sorry, cube root of 5. So look at this. So inside this, so the cube root of 1 is 1. The cube root of 8 is 2. So 5 is between 1 and 8, isn't it? Yeah, it is between 1 and 8, isn't it? So it's going to be between 1 and 2. So that means it's going to be 1 point something. So you don't have to do it in the calculator. I know it's going to be here because it's between these two perfect cubes. So this is going to be cube root of 5. Cube root of 10. What's that between? 27 and 8, right? Cube root of 10. Yeah. Cube root of 10. That's between 8 and 27, isn't it? If it's between 8 and 27, then my answer should be 2 point something. So it should be between 2 and 3, shouldn't it? Okay, so I'm going to put that right there. So that's cube root of 10. Cube root of 50. That's between 64 and 125, right? So my answer is going to be between... Oh, actually, no. It is 27 and 64. Right? So 50 is between those two. So it should be between 3 and 4. So that's going to be cube root of 50 right here. Next one is cube root of 100. Yeah, there's my 4 and 5, right? So 100's between 4 and 5. So it's going to be, my answer should be 4 point something. So, and cube root of 500. It's between 7 and 8, isn't it? So it's between 7 and 8. Now, does that make sense? So it's going to be, my answer is going to be a 7 point something. All right, questions? Hopefully this is actually pretty easy. A lot of stuff you can do in the calculator if you don't know your multiplication very well. Make sure this goes in your notebook. And your practice, you have about 10 minutes to work on that. So please, you can get almost all of it done. A lot of people last class got it done before the end of class. All right, like, share, and subscribe.